In Mastercam 2025, we introduced the Analyze Deviation tool, and this allows us to compare two sets of data. So it can be between two sets of surfaces, it could be between surfaces and curves, it could even be between surfaces and points. Now, we had a What's New video on this that introduced the function and showed a little bit about how to use it. But now let's take a deeper look into this function, as I'm sure you'll be surprised to see how versatile and flexible this tool is. So you might be wondering, what else can this function be used for? Well, this is a measuring tool, right? A really awesome measuring tool. So let's look at some scenarios. In this example here, we might have a case where we're trying to figure out if a tool can fit into this area here. So what would we need to do? Without the Analyze Deviation tool, we can right-click and choose Analyze Distance. But if we did that, remember, we need to pick geometry to measure between. And depending on the entities that's on your screen, you may not have that. So what do we need to do? We actually need to spend some time to create geometry. Now, conveniently, I have geometry already created on a level, and I just turned it on. But now I can pick, for example, that point to, let's just say, another point here, like this point here, right? And you can see that, okay, this is 50 millimeters, right? But I had to create that geometry to do it. So with the Analyze Deviation tool, let's choose surface to surface. I'm going to pick that surface as one entity, hit End Selection, and this surface as the other entity. And we get our Analyze Deviation function panel, but we don't see any measurements. And this is really a good point to kind of stress here. Currently, my maximum deviation is set to 20, right? So anything larger than that, it's not going to show. If I change this to something like 100, we'll now see that we have our points here and our vectors, and I can hover over any one of these, and it indicates that I'm at 50 millimeters. But all of these show that. So that also tells me that this is parallel, right? Or these two walls are not tapered at all. I could also change it to a chord height, which will simplify it, because in this case, these surfaces are pretty flat, so the chord height will kind of show a more clear representation of it. So that's just one good example. Let's look at another one now. So in this particular file, we see that we have darker gray surfaces, right? So the darker gray surfaces here, that's the original geometry. I also have orange surfaces on a separate level, and these orange surfaces represent mating faces on another part, okay? Now, this is going to be a press-fit scenario, so when they're together, these things are going to be pushed. And for this particular application, they need to be within 1/2 millimeter from the original, right? So I need to make sure that this orange surface is within 1/2 millimeter of the gray surface. We also have these points here, and these 2 points are critical locations, and they need to be within 0.1 millimeters from the original. And again, this is a press-fit scenario, so that's what we need to make sure, is that these values are not going to be deviating too far from the original. So using Analyze Deviation, we're going to start with surface to surface. I'm going to pick my original surfaces using the color mask. I'm just going to choose the dark gray. I'm going to hit End Selection or Enter. And then I'm going to choose, for the second set of surfaces, they're going to be orange, the new surfaces. And when I press Enter, we'll see that we have our point grid shown here. And since our point grid is set to chord height, we see the value here. If I change it to UV points, now the points are going to be spread out really along the UV curves of those surfaces, which is kind of why you see that twisting there. And if I hover over any of these points, I see a 0.07, I see a negative 0.1, I see a positive 0.3. And if we look at our scale here, we can see it goes from 0.3 to negative 0.1. And even up top, we see the maximum and the minimum positive and negative values. It's 0.35 to negative 0.1. So they're all within our 0.5 deviation. Now let's look at the points. So if I do a Analyze Deviation and I do point to surface, one key thing to identify here is our function prompt is telling us to select the points. I'm just telling you that because it's asking for the points first, right? So you might be wondering why you can't pick a surface. I got to pick the points first. So there and there. And now it's asking for the surfaces. Well, the original surface was the gray one, right? So we're going to see how close these points fit to that gray surface. And if I hover over these values, you see this is 0.05 and that's 0.07. And you can see with our grid here, we see the maximum and the average. And in this case, they're both within the 0.1 millimeters, so we're good. So this is measuring between a surface and points. Now, one last example here. We're going to bring up this analyze deviation file, which is this blade file that we showed in the What's New video. And if I zoom in on this geometry here, you'll notice that there appears to be a gap between this wall and this surface. Now, we don't know if there's a gap there. This is a pretty old file, and I've seen CAD files where the display is set to simplify the display so it appears to be a gap, but there really isn't. In this case, there is, and I can check that. I can specifically measure that. So I'm going to go to the wireframe tab. I'm going to create a curve on one edge. I'm going to create a curve on the edge of this green patch and then of this blue patch. So I have two curves. Now let's measure between them using Analyze Deviation on the Home tab. And I'm going to choose Curve to Curve. Now we're doing a simple chain here, right? So I'm going to select this chain and then this chain here. And as you can see, we get our grid. If I zoom in here, we can hover over any one of these and see the deviation values. In this case, it's 0.28 and some change, so 0.28 millimeters distance between these curves at the maximum value. So this just shows us how we can measure the difference between these curves. Okay, so as you can see, this is an extremely versatile tool. Think of it more as a measuring tool. And the next time you find yourself creating geometry because you need to measure some entities, consider instead using the Analyze Deviation tool.